Welcome to Getting to the Mat of It, CorridorKey and the Future of Keying. My name is Philip Wolf. As a member of the Education and Outreach Committee of the Visual Effects Society, I'm happy to introduce you to today's fireside chat, made possible by Eyeline Studios and its amazing team. Thank you. But before we get started, we would like to highlight that all of you are able to submit questions for the following Q&A. If you're on Zoom, please use the Q&A feature at the bottom of the window. If you're on YouTube, please write your questions into the live chat. But now to why we're here today. Let me introduce you to Nico Pöhringer, a filmmaker, visual effects artist, and co-founder of Corridor Digital. He is a core member of Corridor Crew, where he helps break down filmmaking techniques, visual effects, and emerging technologies for a global audience of over 17 million people. With a background in cinematography, post-production, and even stunt work, Nico has played a key role in shaping Corridor's signature style, combining practical filmmaking with digital effects in a way that is both educational and entertaining. His work spans short films, branded content, and viral online series, often pushing the boundaries of accessible visual effects and real-time workflows. But one thing to especially highlight is his ability to translate complex visual effects processes into clear, engaging insights, helping demystify the craft for both aspiring creators and industry professionals alike. Paul de Bevec. His pioneering work in photogrammetry, HDRI lighting, LED volumes, and photoreal digital human characters has been used to create key visual effect sequences in movies such as The Matrix, Benjamin Button, Avatar, Gravity, or Blade Runner 2049, earning him 3 Academy Awards, one of them as recently as end of last month. Congratulations, Paul. He has also received the Simply Progress Medal and a Lifetime Achievement Emmy. He is a VS Fellow and serves as Netflix Fellow Content Production Research, overseeing research and development for visual effects and virtual production with computer vision, computer graphics, and machine learning. And now, without further ado, over to you, Paul.
Thanks so much, Philip, and thanks to the Visual Effects Society for putting this special session together with Nico Pöhringer about CorridorKey. That's getting a lot of discussion these days. It's very exciting technology. I'd like to start by dialing it back a little bit, just hearing a little bit about you first.
Okay.
How did you first get interested in visual effects, and how soon after that did you have to key your first green screen?
I got interested in visual effects at a pretty young age. I actually started off with a desire to become a pyrotechnician. I wanted to be the guy that blew stuff up on the movies. Watching the original Star Wars films, Independence Day, the movie Magic series on the Discovery Channel, like all that stuff just made me fall in love with how the illusions were done. And I love action films, sci-fi stuff. I had to pull my first chroma key. First it was actually a blue screen key in 8th grade because I wanted to make a Star Wars fan film. And I had to learn how that worked so I could put myself into an X-Wing. I realized it was very, very difficult to do so when you're shooting on DV with 4:1:1 chroma subsampling. And since then, it's always been a struggle, but worthwhile.
Very cool, very cool. Tell us a little bit about Corridor Digital. This is your current outfit. Mm-hmm. How did that start, and what exactly is it? A visual effects studio? Is it a YouTube channel? What all's happening there?
Yeah, it's a good question. So Corridor Digital would be kind of the overall company. And we started off as effectively just a production company. Myself and my buddy Sam, we had just moved out to Los Angeles from Minnesota. We were 21 years old, doing low budget films, things like that. But the one ace we had up our sleeves was we could do CGI, we could do visual effects. And back at 2008, 2009, that was a great asset to have. It was around 2010 when YouTube started the partner program, and a lot of what we had done to learn was to make short videos that would go online, and realized that we could just continue doing that as our job and make an income stream off of it. Mm-hmm. That's how we pivoted to YouTube, and we've been doing it ever since.
Very nice. Well, congratulations on all of the success. I know a lot of our VES members have enjoyed hearing about visual effects of movies, new and old, mm-hmm. and all of your other material that you do. You also have a good track record of trying out the new techniques as mm-hmm. they come out, and not just traditional CGI stuff, but also things that are getting into machine learning. Mm-hmm. And I recall a little while ago, maybe a couple of years ago now, you actually worked with some of the Deep Face Labs software to do some face swaps. How did that go for you, and what did you learn from that?
Well, the idea of being able to swap the face of your actor is, up to that point, it was something that'd be relegated to like a huge endeavor by, a visual effects company with 3D scanning and all those kind of things that would be very resource intensive. So to us to have this ability to kind of pull this visual trick off without that kind of resource was, it was really inspiring and motivating, and something we jumped into to experiment with. I actually ended up doing a little stint with Deep Voodoo, the team created by the South Park guys, because of my background with the deep fake stuff and that kind of machine learning aspect of things. And it also opened the door into not just training like a deep fake so you can swap the face of your actor, but like just the world of training neural networks and all the different open source projects and research projects that we're beginning to drop online. Everything from infill on a video when you want to remove wires or a rig to slow motion, extra, interpolating an extra 10 frames between, the 2 frames that you have. All these tools were things that we're beginning to develop in the world of machine learning. And to me, were super exciting because, technology is a lever, right? You're using it to multiply your output as a human being. And for us on YouTube, if we want to achieve anywhere close to the quality of media that you see like in a film, like a major motion picture film, like a high budget film, we need to be using the biggest lever we can find in order to get our output up to that level. And that's something we are always experimenting with, always trying, trying to find out what's the next thing that's going to give us that creative edge as artists and filmmakers. So, machine learning showed a lot of potential there, and just dove right in to see what I could learn.
Very cool. I also recall you used some generative tool technology to dabble in the world of anime style as well with these rock, paper, scissors movies. I think those got a lot of attention.
They did.
What was it like working on those, and what were some of the takeaways from those projects?
Well, we've done these series of live action anime videos on our channel where we take something that usually wouldn't be as dramatic and operatic as an anime thing, like for example a baseball game, and then you try to make it as epic as possible and as anime as possible. And I pull a lot of inspiration from the way anime approaches drama and action and all that kind of stuff. And back in 2023, the first Stable Diffusion models had dropped, where you could just take one image and make it look like another image. That's basically all you could do. But we realized through a combination of using this, training our own models, and I had all this experience training with the deepfake stuff, training our own models and using a bunch of visual effects tools to try to enforce stabilization and things like that, we could effectively reskin our videos to look like it was a hand-drawn cartoon. So we did this anime parody called Anime Rock, Paper, Scissors, where 2 princes, twins, born at the same time, must have a rock, paper, scissors battle to see who gets to claim the throne because their father has passed away. It was super fun, and we dropped the video, and it blew up when it came out. Of course, there was positive feedback and negative feedback, as one runs into when it comes to this kind of stuff. And for us, it was a giant experiment. It was a thing to experiment with, like, what do these new tools offer us? Because as I mentioned, like, to us, the technology that's developing is what's enabling us to do things that I thought would only ever be possible if it was a giant budget film. And it was a fantastic experience. I learned a ton. I met a ton of people. I've learned all the different points of view on the internet about using these kind of tools. But it's all part of the experience of trying things. We have a kind of a motto or philosophy at Corridor that, like, what you make should make people feel something. It doesn't always have to make them feel happy. But what you don't want is apathy. If people don't feel anything watching your stuff, then you're not doing a good job. You either need to challenge them, make them think, make them excited, whatever it is, but you need to make people feel something.
Very cool. Well, now, talking about CorridorKey, what was the initial idea behind it? Was it more of a creative project that had a need, or was it a technical problem that you thought needed to get solved?
A little bit of both. From doing our visual effects artist react show, I see a lot of art projects that have someone that steps in to also solve a technical problem or engineering challenge within that art project, that unlocks that art project to happen. And that's been super inspiring. And a lot of what we do at Corridor is just experimentation. We don't always have, like, I have the script that I just can't bring to life because we don't have the technology. Like, that doesn't happen very often for us. But in this case, we actually did have one of those situations where we're filming this Dungeons & Dragons show. I know it's really highbrow.
This is Son of a Dungeon.
Son of a Dungeon, yes. And it's actually the 3rd season. And the way we approach the show is, you do a tabletop game. It's effectively improv theater around a game board. And then after you film these sessions, you tell a story together, you edit that down, and then we want to bring it to life. We want to recreate those scenes. And we actually try to do it in the world of the game. So we actually 3D scan the game board and, all the dungeon pieces and monsters and everything, film ourselves on a green screen and put ourselves into that world, reenacting it. And of course, in the past, this is your traditional pipeline of film on a green screen, motion track the footage, take it into a compositing program. You're all familiar with it. It's what we've been doing for the past 20 years in visual effects. The problem with that is that it's time consuming and it's slow and it's hard to do. And when you're a team of 5 or 6 people working on a project, you can't do 500 effect shots in 2 months. And so going into the most recent season, there's a couple of new pieces of technology we wanted to use. One of the main ones is the ability to take your footage and run a couple different AI processes on it to delight the footage, to create an albedo, to create a normal map, and then to take that, project it in Unreal Engine on a card, and then let the world of your Unreal Engine environment light that subject. So you kind of get to skip out on compositing a little bit because it's being lit and rendered all within that 3D scene. There was one problem with that process, which is we didn't have a solution for green screening outside of the traditional green screen process. And that gap is what inspired me to jump in to try to solve it with something that was good, fast, and as automatic as possible. And so I ended up making CorridorKey.
Very cool. Now, through your visual effects work, going back to when you were 8 years old, you're no stranger to keying software and pulling a mat. And there's lots of software out there for it. Even some of it has been infused with some technology from machine learning these last days. What are some of the things that that you knew as traditional process, and what were the things that still kind of bugged you about them?
The traditional process is pretty robust, and if you shoot with a good green screen, you can pull a good key. And that wasn't so much the problem that I was dealing with. It's more that, okay, you're shooting on a green screen, you need to put some tracking markers down. Okay, well, now I have to go in by hand and figure out, am I gonna do some garbage masking? Am I gonna try to make them a different color that can still kind of key out? Okay, it's a solvable problem, but now you're spending 5 minutes solving that problem per shot. And then what about when you have the edge of the green screen, pops into frame? So okay, I gotta go for that and garbage mat that out as well. This character is wearing an off-green color clothing, so we're gonna deal with that. But they have fine hair, so it's now I have to pull 2 masks. And these are all things that you can solve, and they don't always take a long time to solve. But the problem is when you take 5, 10, 20 minutes, 30 minutes per shot, and you want to do hundreds of shots, it really adds up. And one of the other evolutions that we're running into is when you generally do visual effects, you do your edit, you have your shots, and you kick those out for visual effects. But in this case, when we want to reenact a scene in this 3D world, it's much more of a situation of doing an entire take, a 1.5 minute long shot, and then do the effects on that whole shot, and then you can edit that as you wish from there, as if it was just the footage you got. But to approach a shot like that with the old-fashioned keying system, having to do it all by hand, kind of step by step, working through it, it gets really, really time-consuming. So I figured, we're in an era where my car can drive itself, I can talk to my computer. Why am I still doing color difference keys on my computer?
It should be solvable at this point.
It should be solvable at this point, exactly. And so that's kind of what kicked me down that road. But the biggest things at the end of the day that, to me, hold back color keying is any sort of lack of intelligence in terms of knowing at least okay, here's the subject, here's the background, let's start working with that. Plus, so many cameras still have chroma compression, and that causes issues too. So yeah, I want it to be fast and easy, as easy as possible.
Very cool. So we had some fun a couple years ago with a video that we worked on recreating the sodium vapor matting process. Were there any things you learned from sodium vapor that helped with your thinking for CorridorKey?
Oh yeah, 100%. The sodium vapor video we did together is the exact inspiration that led to CorridorKey happening. And it really, it really just boiled down to something really simple, which was this concept of unmixing. I always kind of understood it a little bit until we made that video, and I finally really grasped it, which is the sense of when you film somebody on a green screen, you need to make it look like they're filmed on a black background if you want to truly composite them. And I believe you actually gave me a breakdown that guided me through the process when we were making the sodium vapor video. And you brought it along here too,
I think
you?
I've got a couple slides. Actually, if we could flip to a slide over here.
Yeah.
So these are a couple of images that we got from the sodium vapor matting camera. And it was like two cameras. One of them shot the actor in color, but it blocked the yellow of the sodium vapor background. And the other one only could see the actor silhouetted against that bright yellow screen.
Right.
And so with a little bit of cleanup, you end up with your foreground element on black, which, as we know, is actually really important for your foreground element. And then not so much like the alpha channel, but actually like the inverse of the alpha channel, the holdout matte.
Right.
And if you have these two things, compositing becomes very straightforward because you just have your background. So there's our little Martian landscape that we used.
Yep.
And all you need to do is multiply it by the holdout matte. In optical compositing, you print these two things together. And then you do another pass where you just simply add the light from the foreground element on top. You don't have to multiply it by alpha or anything. You just simply add the foreground on top and it drapes in, and pretty much everything works.
It's like magic.
Yeah, the anti-aliased edges, the transparent veil, the motion blurred hand, all of that, it kind of works. Now, if this had been filmed on green screen, you're actually starting with a little bit of a harder problem because you've kind of jammed these 4 channels of information of your RGB plus your matte into the 3 channels of what the camera can shoot. And in particular, your green channel ends up having the image that you need for the matte, that bright background, but it also has the green channel of the actor on it. So something that can be a step that you try to deal with if you had filmed your actor on green screen like we're simulating here, is maybe you'll multiply it against the alpha channel to try to get all of that green to go away because you don't want that in your composite. But the problem is that you end up with a lot of pixels in the motion blurred areas, around the edges, in anything that's semi-transparent, that ends up having green. And then when you bring it into your composite, you're going to get all these green fringy edges. Or if it were shot on blue screen, you get blue fringy edges. And there's many movies over history that unfortunately had to deal with this problem. So if you look closely, you can see there's lots of stuff in here that we don't want. But if we did have an unmixed foreground element that showed the actor on a black background, then all you have to do is add it in to the background multiplied by the holdout matte, and you can get that nice effect that we were looking for. And that, to me, I think is one of really the most exciting things about CorridorKey, is that it doesn't just try to get you your alpha, which is certainly useful, but it gives you an unmixed foreground element.
Yes. That was the biggest thing I was trying to solve here. And like, after doing the sodium vapor project with you and kind of like really illuminating this value to the unmixed background or unmixed foreground, I really started looking for some sort of research project or tool that would do that step. And there's so many amazing matte generating programs out there and research projects, and there's so many amazing auto-roto and AI segmentation projects, but I couldn't find a single one that did that predictive unmixing. And granted, if you have a perfectly flat green screen, you can effectively do the unmixing just by subtracting that color from the semi-transparent pixels, which a lot of people do, and that's how you still get great green screen keys in films these days. But what if you have some shadow on your green screen? What if you have some wrinkles on your green screen? Now you're getting back into the weeds of isolating little areas and having to subtract those colors. It's like, yeah, there's got to be a tool that can just do it. And yeah, that's the problem I set out to solve with CorridorKey, which I assume we'll get into in a minute.
Yeah, let's get into it. Now, one of the things that CorridorKey, you've trained a model that gives you alpha and the unmixed foreground.
Yes.
You also give it some input. You give it this thing called an alpha hint.
Yes.
So what is it, how do you get it, and how good does that need to be in order for the process to work?
Yeah, it's a good question. So my philosophy with working on CorridorKey here was, first off, I'm not a machine learning expert by any means. I'm very much a jack of all trades, thanks to kind of like my YouTube environment. And I wanted to set out with a mission of starting simple. It's like, let's make sure this is high fidelity so I can use it. Let's make sure it works with green, and let's focus on the unmixing. My job that I set out for myself was not to focus on the alpha generation, because there's so much good alpha generation tools out there created by teams of incredibly smart people. And so getting into that realm, I'd just be trying to reinvent a wheel that's already been worked on by very talented people. So I wanted to work on the unmixing program, or the side of things. So I have okay, how can I kind of take from this world of alpha generation that already exists? Also, as a user of the software, how can I say these little black bits that are on the screen, those are tracking markers, get rid of them. Or these little black bits on the screen, that's actually debris from miniature I blew up, keep them. How do you differentiate between the two of those? And to me, the easiest way to do it is with the black and white mask, right? You can just do a classic color key. You can do AI segmentation. You can do a mix of the two. There's so many different ways to create this black and white mask, which doesn't have to be good. It just has to be there to say, keep this or delete
Can
this.
it be a little inside the edge of the,
It can be a little
bit
inside, a little outside, it can be
It's-
a little soft. In fact, part of the process of training CorridorKey.
Can it have a little hole in it somewhere and that gets fixed in? or-
Actually, the hole is where the problem comes in. So it's truly going to be like, if there's a hole there, you want the hole to be there. So it's going to listen to you and try to work with that. If in the object, that object isn't green, it'll start to be like, oh, maybe they didn't mean that. It'll start to kind of be wishy-washy on it. But at the end of the day, the alpha hint generally has to preserve what you want as white. Beyond that, the program can kind of interpret the rest. But the idea is that you can inform it. It doesn't have to be good. You can truly just eyedropper the background if it's on a green screen key, or you can use like Magic Mask or Segment Anything, any one of those segmentation tools. And it can be rough. And you pass it through, and it takes it from there.
Okay.
Yeah.
Now, these models that are based on training a machine learning algorithm, they need training data.
Right.
You got to choose it wisely, and you have to get enough of it. How did you train your model, and what was that process like?
So I did a lot of searching for training data that was out there, and I found various data sets that people had created of subjects on a green screen. A lot of it was somebody taking, say, stock footage and keying it and then recombining it with the background. The problem with a lot of this footage is that when it's real-life footage being keyed, you're not getting physically accurate edges. You're getting stuff that looks good, but it's not getting the physically accurate linear unmultiplying or unmixing of light, right? Which is, if we're going to train this model how to predict and fill in these colors, it needs to have that physical accuracy. And I figured, well, I can do that with a 3D program, right? I can just put some objects on a 3D background, render out some passes, and I'll get the perfectly physically accurate, mix of color and light and foreground and background objects. And once again, searched around, and no one had really built one of those data sets. And I guess my whole experience with a lot of this is that there's a lot of things out there that are doable still, that people just haven't tried because everybody's busy working on stuff. You can't take anything for granted. Not all problems have been solved. And some of these things weren't necessarily complicated. It was just a matter of sitting down and spending 1 to 2 weeks building out all these procedural systems to randomly swap in a 3D model against a different 3D background with a different 3D camera motion, and then rendering all that out on our computers and stuff. And eventually we built out, the team at Corridor and I built out this data set of about 400 shots, each 48 frames long, that had a background pass, a foreground pass, 8 alpha channel pass, and something else I can't remember off the top of my head. But that was basically it. And we put all that together and started training from there.
Okay. Was this like a massive, like you had mainframes of computers, an entire data center next to a waterfall going, or could you do it on what you had in-house?
We did it on what we had in-house. To be fair, we have nice machines. We're using Puget Systems computers, so we put a bunch of 5090s to work on it. So it's not it's not exactly like my one home computer that's working on it, but it's also not a data center. You could render out this data set in a couple weeks of grinding on your GPU.
You're saying 400 shots, 2 seconds each.
Yep.
Which is, this is a tractable amount of
yes.
training. Now, how did you choose what's in these shots? Is it like toy boats and rocket ships, or what all you got in here?
Yeah, so I tried to pull from our experience of filming on a green screen and just think about, what are we going to be filming? What have we filmed? Obviously, people are a big one. People with props like swords and things like that. That's always a challenge with AI segmentation. Is like, is this stick that the person's holding like part of the person or not? And it flickers in and out. So there's a lot of that, but also things like hair, soft motion blurred edges, fuzzy objects, abstract objects, things like that. Just anything that we could kind of work in that would really try to push the computer to be like, hey, here's a color and it blurs off to green. Here's an alpha hint that kind of implies keep this part, figure out that unmix, and it'd be from like, here's a person, I can tell what it is, to here's abstract shapes, try to just figure out the unmix from there.
Interesting. Okay, so these people, like where are these people coming from? These are photoreal
Just
digital
3D
humans,
models.
or just
like
random
metahuman models,
Yeah.
things like that. Just really any things you could buy in the Unity store,
Okay.
Unreal
And
store.
then for things like like hair and fuzzy stuff, you're just dealing with what CGI can do, and that turned out to be good enough. How about like dynamics? Because a lot of the shots that you apply it to have people head banging and getting all of that stuff. Is there anything like that in the training data, or did it pretty successfully manage to generalize to those kinds of things?
There is some of that stuff in the training data, but it generalized really well, which was very exciting when it did. Because this stuff's always so stressful when you're training a machine learning model, because it's a black box. You put the data into it, you let your computer crunch on it for like 24 hours, you come back, you render a shot. It's like, did it work? And then if it works, like, cool. But is it going to work on the next shot? Is it going to work on the next? Like, you don't know until you try. So it did generalize, and from what I can see, it's generalized pretty well. There's certainly improvement to be had, for sure. But the big thing is that I didn't train CorridorKey to have any sort of temporal awareness right now. It's just a single frame, look at the frame, pull a key from the frame, just like how a chroma key plugin or feature would work. It's just looking at that one frame. So things like that dynamics and people moving, it's all there in the data set with the anticipation of down the line training newer models that have temporal awareness. But for now, what's just in an image is all that really matters. And from my experience here, as long as you just give good representations of some foreground object on a background with edge challenges, fuzz, out of focus, motion blur, that kind of stuff, some transparency, reflections, just the more examples of that, the better.
Interesting. So getting more examples, like you have your 400 renderings.
Right.
A lot of machine learning techniques do training data augmentation, which means they kind of apply various transforms to it to make it feel like you have more than you really had. Did you do any augmentation of the training data? I know, flipping it, scaling it, rotating it, putting it out of focus, things like that?
Yeah, actually I did. There's a great example here. Let's go to my computer screen if you don't mind here. I'm gonna go full screen on this. Boop. All right, so let me show you this real quick here. So this is an example of the output I would get when I was training this model here. So here's we built two different procedural systems, one in Blender, one in Houdini, that would procedurally change materials, objects, lighting, background, and camera motion. So you can kind of just hit a button, get 100 variations of different renders right away. So what you see on the left here is what gets passed into CorridorKey as its input. And this is actually a live composite that happens on the fly when the model's training. And in this case, it happened to swap out the background with a real picture of our green screen with a bunch of tracking markers and tape on it. But that only happens about 25% of the time. Otherwise, it's just a different green background that the object was rendered with. And then what I end up doing is I take this ground truth, as we call it, or ground truth, foreground, background, and alpha channel, and I do another composite on a random background color. I then take the predicted output and do the same composite on that same color. And then you can compare these two and be like, okay, well, how good is the predicted alpha, the predicted foreground, how good is it faring against the real thing on any color background? So this basically opens up the training data, makes it not just green screen data, but lets it compare against colored backgrounds of any variety, and it kind of unbiases that unmixing a little bit. Because for example, let's say I only did pink backgrounds. Well, the program could maybe predict a pink fringe on the output, and hey, it looks good, it matches the pink, and now you have this weird biased pink edge on all your shots. And the thing is, not only is this doing a comparison in like RGB pixel space, but it's also doing a comparison in YUV pixel space. So YUV being Y being the luminance, UV being the chrominance, and you can just do a chroma comparison. You don't have to worry about the luma at all. And you can even multiply that if you want to, say, take any small errors in chroma and make those errors big to really push the model in a certain direction without having to worry about any luma matching. So there's interesting things you can do when you kind of move to different color spaces.
Okay, so if I'm understanding this, what you're doing is you're training a model, you're adjusting the weights of this model as you train it so it gives better and better results. And the kind of results you want it to be able to get, that you judge it against, is how well, if I estimate the unmixed foreground and the alpha, how well can I comp this thing into this new background and have it actually look like we had rendered that object on that new background?
Yep, exactly. And once again here, random color background, I can also do the same thing on a neutral gray background. And this is nice because you're doing both at the same time. So not only does it have to work against crazy colored backgrounds, it also has to work on neutral gray backgrounds. So it's really pushing the model to not cheat. Because an AI model is going to try to find ways to cheat.
Yes. They're very clever that way, yes.
Yep, and it took a long time to figure out the right, settings for the soup to cook correctly, And you can see the different variations. Like here's the ground truth alpha, and you have the more blocky predicted alpha as it's training up. And then actually, let me show you a different screen here for the predicted foreground. So let's see here. I'll define it real quick. So another interesting thing about this is you're probably familiar with the concept of pre-multiplied versus straight color objects.
Yeah, pre-multiplied alpha is kind of saying the same thing as your foreground element is against black already. It's like alpha's already multiplied, which means you don't need to multiply it on it again.
Yep, exactly. But straight color is this weird situation where there's not a single transparent pixel in your image, which is a physically impossible thing to capture in real life. So
this is the image that you would need to multiply by alpha to turn into your foreground on black.
Exactly. So let's say this is your shot that you're trying to key, right? So crazy motion blur, all this kind of stuff going on. You're going through your different systems here. But what we were trying to get here, this is our ground truth straight color. So that motion blur is now a solid color smear. Same thing with this hair. There's no transparency whatsoever on this image. You take this image, you multiply it against your alpha channel, and you get, of course, your nice pre-multiplied on black image. So what this model is trained to do now, it's trained to take this input image of, say, anything on a green screen, this guy on a green screen, and it's predicting the straight color unpre-multiplied output from that. So not just the object on black, but any pixel that's transparent is being predicted as fully opaque without any background
And this is
color
kind of
in it.
mirroring a traditional keying process you might get involved in, of kind of smearing the edges over into the motion blurred region to get rid of mixed pixels.
Exactly. And initially I did start training the model to predict pre-multiplied images, but I realized that it was more important to push that color information up into the foreground as much as possible. Not only does it give you more control later on, if you want to tweak your alpha channel, but it's forcing the model to like truly unmix that pixel. It doesn't have to predict that pixel at 1% opacity. It has to predict that pixel at 100% opacity. Well, 0% opacity. Depends on if your opacity is 0 or 100 and you're 100% opaqueness, I should say. So yeah, this is an example later in the training process. Here you have ground truth on the left and the predicted output on the right. And as you can see, they're pretty dang good. They're pretty close to each other.
There you go.
So it ends up training, it ends up getting it right after
learned well.
enough time. Yeah.
Very nice. Now, when you're looking to see if a composite has been good, like your eye just goes straight to the edges, right?
Yes.
Like it's all about the edges. Like every compositing case is an edge case. How are you able to get this model to know that edges are important? Do you have to intentionally try to focus where it's paying attention to in particular areas you think people are going to care about?
Yeah, that's a great question. So you're right, the edges matter. The edges matter more than anything else. And so another process here was to create something called a spatial weighting map, or spatial weights. And so if you look at this image here with the white outlines, effectively what I've done is I've taken the ground truth alpha channel, the alpha channel we rendered out of our 3D program, and I said anywhere a pixel is semi-transparent, so somewhere between 0.001 and 0.999, take that and consider that an edge pixel. And then dilate that area by 10 pixels. So that's our actual edge. If we want to say focus on the edge, that's how we identify our edge. And then we also have the region inside of that, where anything's at 1 alpha, treat that as the inside, and anything at 0 alpha, treat that as the outside. So I can use those spatial weights, so then when I train the program, I can say hey, any errors that you detect within that edge, multiply that error by 10 or 20, so it really affects the neural network as it trains. Same thing for the background. The background is really interesting here because at the end of the day, it gets multiplied against 0. And if you're trying to predict some value that gets multiplied against 0, you're never going to be able to predict
that. That means the model might just start doing completely crazy stuff out there.
Yes, which took me about a week and a half to figure out why my model was exploding. And then eventually I got down to oh, that's right. I'm multiplying the background by 0. So as it tries to predict the foreground elements to be there, any answer is correct, and it goes crazy. And in fact, if you kind of look at the foreground prediction here, so I ended up weighing it down, but that's why you have this kind of weird gray background with smudges there, is because that's effectively been turned off entirely from the training network.
Very good, very good. Okay, so it sounds like you trained this model. That required firing up a lot of machines and warming up your building a little bit for a while.
Yeah.
But suppose we're actually using that model and we're trying to key some shots with it. What kind of computational requirement is necessary? Like, do we need a really massive graphics card? Does it take an hour to get a key? Does it take a few seconds? What's it like using it as a user?
Using it's actually gotten pretty easy now, much in part to the open source community that's helped out around this project. Because we have the benefit of being a big YouTube channel, when I put this project out, we made a whole video about it. A bunch of other individuals who are passionate about this idea and wanted to help out jumped in. We have a Discord channel, the Corridor Creates Discord channel, and people immediately optimized my code. Because once again, I'm very much an amateur programmer. And people identified like, oh, the way you're running your convolutional neural network here could be simplified. Oh, you have an extra dimension that had to be initialized to do the way you're firing up this thing, get rid of that. And now you can run it on a GPU that has 6 gigabytes to 4 gigabytes of VRAM on it. So it's pretty accessible. You'll need a NVIDIA GPU of like, I think 2000 series or later for it to be GPU accelerated. Any of the M series Apple processors can run it just fine. I think AMD cards are now working as well. But it's much more doable, usable, and runnable. I trained it on an RTX 6000 rig. So I was like, I'm not gonna worry about VRAM yet. I'm just gonna get it working. And the open source community has been super helpful in taking it from there.
Very cool. I want to ask about that a little bit more, but we have about 8 minutes more in our conversation before we're gonna open it up to questions that are coming in over the chat. So if you have access to the Q&A function, feel free to input your question, and we'll try to get to that. You mentioned a bit about not being, in your estimation, an expert programmer, but you've created this like pretty complex piece of software. So I assume that you might be using some AI coding assistance for some of this. What was that process like? And do you feel like, is this really something that everybody should be doing at this point?
Yeah, honestly, it was really exciting and exhilarating. It was fascinating. It's like I'm the kind of guy, who grew up building Legos and Kinects, and like I like building stuff. I think you do too, based on what I see around me here. And like the idea of this is something I struggle with a lot, which is this concept. As a filmmaker, like it's hard to own your tools, right? If you're painting, you own your paintbrush. You got your canvas, like you got your easel. It sits in your house, right? I don't have to log into my paintbrush when I want to start painting. I don't need to update my credit card info on my paintbrush when I want to start painting. And as a filmmaker, especially with visual effects, you're caught in this world where, software development needs to happen, and you're going to use crazy software tools, but that also means that you have to pay for it, and there's this whole, economy around that. And I don't know, I really like the idea of not having to have effectively a middleman between me and the machine and the tool that I want to use. And so I've started experimenting more with coding my own tools, little tools, things like that. And it's really freeing. There's things, we use DaVinci Resolve for all of our editing. I'm never going to ever make a copy of DaVinci Resolve by vibe coding anything like that. And I don't need to. Editing is a problem that so many people have that it makes sense for a company to make a product to serve that. But when it comes to like some weird niche little issue that I'm going to have for some niche project I'm working on, there isn't going to be anybody that's going to develop a piece of software for me. And so being able to do it yourself with vibe coding or whatever is really fascinating and really eye-opening for me.
So Leonardo da Vinci himself would mix his own paints when he's creating all of his paintings. So you're mixing and also unmixing some of your paints at this point. You mentioned the open source community, and that's actually a big part of the story of CorridorKey at this point as well. How did you decide that you'd want this to be an open source project, and what path has that taken here?
Well, I'm very fortunate in that I have a day job as a YouTuber. So I personally don't need to try to make an income stream from selling software. If somebody's a software developer and that's their livelihood, then it makes sense they'd want to sell their software, but I didn't have to in this situation. At the end of the day, what I want more than anything else is for pulling a green screen key to be as painless and as fast as possible. And if my route of getting there is to make a tool, a proof of concept effectively, make a video about it, get out into the community, and then the community can help me actually take this to its final destination, and that's my goal has been realized. I'm not trying to make money off of this project. I just want green screens to be easy. That's all I want. So yeah, the open source, the community, the people that have been on the Discord, and the people that have submitted PR requests and have been editing with this and making tutorials and their own programs with it, has been amazing, and it's been super inspiring, and has already taken this tool to such high usability levels from where it was when I started. It's
so you release this on GitHub. If somebody, as soon as we're done talking here, wants to go and try to key one of their pieces of footage with this, like what would be the shortest path to doing that today?
Great. Okay, so a couple different routes. I'd recommend Easy CorridorKey. You can just Google that, Easy CorridorKey. It is a standalone graphic interface project for handling shots. Great way to get started. It's a double-click install file. You can sit back, let it do its thing. Runs on Mac, runs on Linux, runs on Windows. If you're trying to get into your pipeline, if you're in DaVinci Resolve, there is a Fusion plugin. Works great. It's by a guy named Ale. It's an OFX plugin. He also has it working in Nuke now as well. And that just pops right into Fusion. It's great because you can take your shot, you can break it off to like a 3D keyer, eyedropper the background, get just the roughest black and white key, pipe that into CorridorKey, boom, perfect shot.
Wow.
It's really nice.
Very
2
nice.
clicks.
Okay. And like, suppose you actually have like a commercial product, right, that you're getting paid to do for a client. Is CorridorKey something that you could use on that project? Is that okay?
Yeah, people can use CorridorKey for anything. It can be commercial, it can be non-commercial, it doesn't matter. You can use it for whatever you want. I do have some restrictions in place, which is around selling the model and access to the model, because right now I don't want it to be something that, well, 2 goals. Like, once again, I'm figuring this out as I go. So it's very much I'm taking feedback from people in the community. I wanted to be careful. I didn't want this to get released and then have one team make a plugin called one thing, another team makes a plugin called another thing, and another company then tries to put it into their program, assuming it's even good enough that companies would try to do that. I wanted to keep it focused, and also, if there's a financial incentive, if there's too much of a financial incentive, then no one has an incentive to work together to solve it. I want it to be very communal, where people felt like they could work together and address problems together and put out features together and not feel like they're going to get ripped off on that. So I'm very much trying to enforce like the no commercial software side of it without prior permission. But in terms of using it, anybody can use it however you want. Like I would love for people to use it all the time, anywhere, on any project. I want feedback. I want to hear what's working. I want to hear what's not working. I just want it to get used. That makes me feel fulfilled when it gets used. So it can be used for anything. It's just, and if somebody does want to make a plugin and sell it, it's not that it's a no. I just want people to reach out to us for permission first.
Got it. Very good. And suppose you have some footage. Do you need it in a particular format? Can it, like, original camera footage, an MP4, EXR sequences, being linear, sRGB? What are the requirements for what you put into this?
Yeah, well, if you're firing up like the plugin in Fusion, it can be whatever. It can be anything, whatever format it is. The CorridorKey works with either linear or sRGB based footage. It doesn't work with HDR values yet. We're getting there. We're working on it. Some other people that are experts in machine learning have stepped into the project and are starting to work with experimental models, temporally aware models. Models that can handle HDR ranges. Once again, that math is a little bit beyond me at the moment, but I'm learning from reading the conversations and all that kind of stuff. But generally speaking, yeah, an EXR sequence works just fine, an MP4 works just fine. Yeah.
Very nice, very nice. And when I went to get a fresh copy of it this weekend, I noticed there was something called CorridorKey 2.0. So this is already evolved. Is there? What are some changes that have happened with that?
Well, CorridorKey 2.0 isn't out yet. CorridorKey 2.0 is what I will call it when I feel like we've reached the point where it truly is a one-click, step back, and it's good kind of level. The limitations right now on CorridorKey is that it processes a 2K by 2K image, or as I like to call it, anamorphic 4K. So the resolution is good enough for YouTube. It's probably not good enough for a film, unless you've cropped it and done your thing. There are some tiling things you can do to tile it and make it higher res.
So if it's anamorphic 4K, I think I heard you got some stuff to work basically at 2K by 2K. So if you want to do 4K, you have to do a squeeze first and then unsqueeze. So will you notice your edges are a little soft horizontally?
It's pretty hard to notice, honestly. Maybe you could notice if you had a really fine grid, but you're already kind of dealing with a little bit of the mush of a neural network, You'd only really notice it on your semi-transparent edges. because as the program, as it gets scaled back up to its full 4K image, the opaque parts basically get filled in with the original detail. So, it gets pretty hard to notice an anamorphic squeeze on a blurred, semi-transparent edge of an object. So I feel like I can get away with it. But in future versions of the model, they should be running at full native 4K.
Okay, very good. All right then. Well, we've got about 14 minutes left, so let's try to get to a couple of audience questions,
let's do it.
if we can. First one is about your data sources used for training, synthetic versus production capture. I think you said they were all synthetically rendered, these 400 shots.
Yes.
But they're asking, were they all rendered in standard dynamic range? Are they rendered in Rec 7 or 9? And what would be the next stuff that you would render or capture if you wanted to improve the model?
Great question. So everything we rendered was rendered out in linear floating points, half float, floating point 16 EXR sequences. So super high data, or high detail, high quality, can be adapted to anything down the line. I have the data set online. Access is restricted. You just simply need to ask me for permission. But if anybody wants to use the data set for an experiment or whatever, reach out. Happy to give you access. And in the future, one of the things that we're trying to figure out right now is some people want to experiment with a model that not only does unmixing, but also can predict the despill and also predict the shadows as a separate layer. So like let's say you're standing on a green screen, take that shadow layer and give you that as a separate layer for compositing. To do something like that requires having a data set where your bounce light is split up from your alpha channel and your diffuse and your background and all that kind of stuff. So some people have been experimenting with that. Another thing we want to experiment with is in terms of temporal consistency. Let's say I have like a half transparent piece of plastic right here, and then there's me, so I'm fully opaque. Well, I'm taking this mask and I move it across my face. Well, in a temporally aware system, it's going to take that half transparent mask and move that half transparent mask across my face, making me half transparent. Because it turns out in our data set, we don't have a lot of semi-transparent things moving over fully opaque things. So that's an example of new data that we need to render out, which is having opaque objects with semi-transparent objects moving across them, as well as multi-subject passes with different alpha channels for each subject, so we can do augmentations as well.
Okay, very good. Yeah, I think that should probably help. Next question is, do you see a benefit in supporting referenced keyed frames? Think about a frame that was professionally keyed, the same character, maybe not from the same shot or even movie. If you think it's beneficial, how would you approach such a scenario in practice? So you professionally key one of the frames and then you can kind of propagate it to the rest of the sequence.
I think that's a really interesting concept. The alpha hint does that a little bit in the sense that the higher quality the alpha hint, the easier the predicted alpha is. So if you key one frame really nicely, that can help inform the model, especially if the temporally aware models end up working. Theoretically, you only need to give it one key. You can just do one image and take it from there. Though I kind of feel like the end result of this whole world of trying to solve matting is a diffusion model that effectively can hallucinate and predict these edges. In which case, if you had a reference image, like do this exactly, and then a diffusion model can predict that temporally across your whole video, that'd be a great way to solve this as well, as opposed to having to try to actually predict the actual values for everything.
Okay, very good. There's a question for studios wanting to use CorridorKey. Would they be able to generate or nest their own training data for specific IP, and I guess have it be super good at being able to key these particular things that we know are going to be in our movie?
Interesting. I mean, I don't think there'd be a problem with that whatsoever. I'm open to it. I kind of feel like pretty much anybody. One of my guidelines on this is that I have a training program. I have all that training data, and my intention is to release that just completely open to anybody as soon as there's a good CorridorKey implementation in the main programs that are out there that's free. So once there's there's a pretty decent CorridorKey plugin right now for Fusion. It's in development for Nuke. After Effects is a little bit up in the air. There's some plugins out there that are being experimented with. I feel like once they mature just a little bit more, so maybe another month or two, then I'll just be like, okay, here's the training data, here's the model, free for everybody. Because that way there's not so much of an incentive to try to be the next person to make a paid plugin. I can kind of keep that community spirit alive. And at which point, if somebody wants to, at a studio, take it and train up their own model, go right ahead. I think that'd be awesome.
Very good, very good. What was the training process? I think they want to hear about the pain that you had with this here. What was the training process like in terms of programs crashing, freezing, slowing down, encountering strange errors or bugs? how did you approach problem solving and correcting these errors? I think somebody's been trying to train a model back there.
Oh man, yeah. I mean, it's so addicting because you're up until 2 a.m. like constantly thinking about new things to try, and you're tweaking it and you're watching it. It trains a little bit at a time. You look at it, you're like, okay. You come back 20 minutes later, you look at it again, like, okay, I think it's progressing. It's just it's like watching a pot boil. You just you keep coming back more and more and more, waiting for it to bubble up. I didn't have a whole lot of crashing, to be honest with you, but the thing that caught me the most is trying to program in the compositing pipeline is really tricky to do without any errors whatsoever, because you need to do true linear compositing if you want to do background color augmentations. As I showed you in the training data there, we're going on a colored background, we're going on a black background, we're going on a gray background. And there's other augmentations that happen as well, desaturation, hue shifting, all those kind of things, contrast adjustments. But if any of that is done incorrectly, in the wrong color space, in the wrong, pre-multiplied versus straight color, et cetera, in a 2.2 gamma versus linear, if at any point in that step you do it wrong, you train the model wrong. And it was really tricky to go through and squash all the bugs and make sure it was always exactly correct. And that also took me about 2 to 3 weeks of trial and error before I figured that out.
Okay, all right. It looked like and we're going to go back to some of my questions here.
Yeah.
If there's any more audience questions, feel free to add them. They'll try to put them in here before we wrap up. I liked how one of your green screen backgrounds wasn't, just like a pure perfect green, because that doesn't happen in real life. And you intentionally took some green screen that you had from some clean plate and put it in there.
Yeah.
Do you have a library of kind of imperfect green screens with various kinds of folds, streaks, tapes, things like that? How big of a library is that?
Yeah, I do actually. In fact, this might be worth me showing an example of augmentations here. Let's see as this goes through. Okay, so apologize for the desktop view here, but it's the best way to show this off. So here's an example of all the different ways you can augment a single frame to take our 400 clips and make them as infinite as possible. So you have your squishes, your stretches. Here's a background swap to a different background plate with yellow tracking markers, different background there, different colors, different hue shifts, different aspect ratios. And you just go through all of this, and you can take that one frame and make so many different examples of data just out of that one frame.
Are these all rendered at 2K by 2K? Or?
Yep. And then these are all on the fly. This compositing happens when it's being trained. So each time it pulls in just the single, if it was to pull in the single frame, it can pull it in to look like all these different systems right here. So this is my way of basically taking my data set of a couple 100,000 frames and being able to vastly increase all the different things that you see with that. And then, I think it's worth probably showing this little bit here. So I did some stress tests when I wanted to see if this was working. So as to your question of do I try other green screens, things like that?
Yep.
Here's an example of what I consider some of the hardest things to achieve in green screening. So, hair, motion blur, some of it's out of focus, spinning around, things in the foreground and background, hard edge light. This shot in particular, to me, would be like the hardest shot to do, right? You see, you're off the green screen and
you're
some
off
of it.
the green screen. Is that in your
motion
training
blur.
data? Did you intentionally have green screens that don't cover the whole shot?
I did, yeah.
And you still train? And does it still come up with an alpha and an unmixed key for the parts that are off the green screen?
It will, as long as your alpha hint is telling it that you don't want to keep that area off the green screen, it will intelligently remove those parts of the green screen. The unmixing on those edges is not as good. It kind of needs to be against the green background to unmix. I have not trained the unmixing against that kind of stuff, but it does work. So here, let's go a little further here. I'm just going to jump ahead to that. Oh yeah, of course. These shots are quickly becoming famous as the the standard CorridorKey shots. A blue transparent cup and a clear transparent cup.
Could you drink some water but make it weird?
And headbang at the same time. Let's get weirder. Yeah. It's so you got green in your shot, you got transparency in your shot. All the most challenging things. Okay, so just to jump ahead here.
And it keyed all that.
As you can see here, Jordan drinking this cup of water. Of course, there's no refraction. I have not trained the model to handle refraction yet.
That's nice.
But handling that green unmixed just fine from the glass. You can still see the glass, which is nice. And this one in particular, pay attention to that blue cup, especially right here. You distinctly see that the cup does not have the green in it anymore. And so the program is managing to get that out of there. There's still a little bit of flickering, because once again, there's no temporal awareness in this model. But that's a perfect example of like what I was really trying to achieve in terms of like the color and mixing. And then if we go to this.
Now, that's actually an interesting case, because that's a case where you have a transparent blue cup. In theory, your matte, your alpha, should have the colors of the cup in there, because the amount of transparency that it has is going to be different for the 3 channels. But you're still doing a monochromatic key. Yeah.
Because the predicted foreground that I get also with a straight color ideally is going to contain that color information with the green subtracted out. And a lot of this really just comes down to like hair and motion blur at the end of the day. Like when you're on a green screen, like what are the most problematic areas? It's hair and motion blur.
Yeah, but these are things that you're using to test it. It's not like you trained with ground truth examples of this stuff. It's actually just successfully taking from the synthetic data you made, and it's extrapolating like surprisingly well to all of these cases.
Exactly. Yep. Yeah. So I didn't train it on these images here. These are. I had to see if it would work on these images, and once it worked on these images, I'm like, okay, I'm onto something. And here's that camera shake shot, and you can see how the motion blur is pretty natural looking. It's not artificially darkening the background. It's not artificially lightening the background. It's hitting that perfect mix between, because you're going to get that transparency through both your alpha channel and your foreground color. They need to work together. So those 2 layers are in tandem, giving you your predicted result. And then, of course, outside of that light poking in the edges once in a while here, there's no background bleed from when it goes off the green screen here. So as you can see, it's predicting this object, this light here in the background that pops in. It's going, okay, that's probably not the green screen, but the rest of it, it's still being understood as the background. And that's kind of the benefit from having what I would almost call a concept keyer. Because it's coming from this background of an image model that can identify what the pixels are, it's effectively going, okay, I know this is a background pixel, I know this is a foreground pixel. By looking at the context of the image and what I'm seeing here, like, this is a foreground pixel. And then once the model kind of can detect that, then it can go, okay, so if this is a foreground pixel and the background pixels are majority green, what should the color of this foreground pixel be? And that's kind of like the next thing the model predicts.
Yeah, I think that's a good point of why this is actually a good problem for machine learning. Because if you just look at an individual pixel, it is going to be a certain amount of foreground color mixed with a certain amount of background color with an alpha. And you get 3 numbers, the R, G, and B that you actually shot, to figure out 7 numbers, which is the foreground color, the background color, and then the alpha that's mixed between. And so the only way you're going to have a fighting chance of that is to use the context of the scene, to use the general trends about, okay, I think there's like a thing here, it has an edge here, the colors over here probably are similar to the colors over here, and then at that point you can make an educated guess. And that's hard for like a hand-coded algorithm to come up with all the ways to take advantage of it. But if you throw a ton of training data and ask the computer to figure out, okay, how do I solve this problem? Just adjust your weights until you start getting good at solving it, then it can actually dial it in, and it looks like you've gotten that.
Exactly, yeah. It's that little bit of intelligence that I've been missing from green screen tools. Because those hard-coded algorithms are amazing at dealing with the color subtractions and unmixing and predictions. But like, but are you smart enough to know that that dot in the background is not supposed to be there? Or that edge of the screen that popped into view should still be background. Like those little things, like they save you so much time as an artist, but you just don't get any of that with just a basic, color difference math formula.
Very cool, very cool. All right, well, I think that takes us to the end of our hour here.
Wow, that flew by.
Yeah, wow. Congratulations on the success of this tool.
Thank you.
Looking forward to hearing more user stories and seeing where you can use to try to improve it and get this used in production more. It's very exciting stuff, so congratulations on that. Thank you so much for all the work you do on Corridor Crew to teach not just our community but the public at large about visual effects and what we do as visual effects artists and technicians to get the story out there. I'd like to thank Eyeline Studios for letting us shoot in the light dome today. This is a fun spot.
It's so cool
for some of this stuff here, and we'll look forward to hopefully getting to tune into more visual effects programs that we have just like this. So anyway, Nico, thank you so much.
Thank you, Paul. Yeah, and I want to say thank you also to you for helping inspire me to make this and giving me a little bit of that guidance when we were doing all the sodium vapor matting and joining me here for this conversation. It's been amazing.
Awesome, very cool. Thanks so much. Appreciate it. It's cool.